Hello dear viewers, welcome back to this channel. In today's video, we'll learn how to use the Siemens S7-1200 Analog Output in real process application. Through this video, you will come to know about the analog output hardware overview, wiring procedure for analog output, hardware configuration and programming in TIA portal software, and finally perform a test operation for S7-1200 PLC analog output. If you're working with VFDs, control valves, or analog indicators and want to control these devices using PLC analog output, then this video tutorial will be helpful for you. A PLC analog output module is a hardware component that converts digital data from a PLC's processor into continuous variable voltage signal or variable current signals. These signals are used to precisely control field devices, such as variable frequency drives for motor speed regulation, control valves, and other proportional actuators for regulating process variables. The selection of analog signal depends on which type of control devices we are connecting with the analog output. Once the type of signal is decided for a particular control device, you can easily select the type and range of signal during analog output configuration in PLC programming.
The PLC we are using in this project is Siemens S7-1200 1214C AC-DC relay. The Siemens S7-1200 supports analog outputs through dedicated expansion modules and signal boards. To get analog output from an S7-1200 PLC, you need to add an analog output module or signal board with the PLC. If you are using the dedicated expansion module, place it on the side of PLC. If you are using the signal board, then mount it on the front side of PLC. In this video, we will use a signal module to get analog output from the PLC S7-1200 1214C AC-DC relay. The PLC S7-1200 1214C AC-DC relay has no inbuilt analog output, so we will use a signal board which model number is SB1232. This signal board features one analog output channel supporting current signal 0 to 20 milliamps or voltage signal 0 to 10 volt DC. You can use either 0 to 20 milliamp current signal or you can use 0 to 10 volt DC voltage signal, depending on which type of device you are connecting to the signal board. To mount the signal board on the PLC, first power off the PLC, remove the CPU's top cover and securely snap the analog output signal board into the designated expansion slot, and finally attach the CPU's top cover to the PLC. After mounting the signal board for analog output module, the terminals on the SB1232 signal board will be found as positive terminal 0 and common or return terminal 0M. Now, for monitoring the analog output signal, you can connect voltmeter or ammeter to the PLC analog output. For controlling devices using the PLC analog output, you have to connect that device with PLC analog output, maintaining the proper polarity for connection between the PLC analog output terminal and the device input terminal. In this video, we will control speed of an AC motor using a variable frequency drive, which will be connected to the PLC analog output. So go for connection terminals for VFD input and wire the positive signal from your VFD input to the PLC AQ0 terminal. Now wire the negative signal or ground from your VFD input to the PLC AQ0M terminal. Here we will select 0 to 20 milliamps as control signal for VFD input, which will govern the VFD output frequency. So in the step of PLC programming, we will configure the PLC analog output to provide 0 to 20 milliamps DC signal. Now, before to proceed for PLC programming, let's take a look at on what working principle the Siemens S7-1200 PLC provides analog output. A PLC analog output module uses an internal digital to analog converter to create analog signal. The PLC processor generates a digital value representing the desired output, and the digital-to-analog converter translates this into a continuous electrical signal to control devices like valves or drives. In Siemens PLC, converting digital value range for digital-to-analog converter is 0 to 27,648, which is finally converted to electrical signal in the range from 0 to 20 milliamps current signal or 0 to 10 volts voltage signal. The converting digital value comes from the PLC processor, which is a calculated value based on the process demand. In this project, we will use a variable frequency drive to drive an induction motor at various speed. The induction motor has a nameplate speed rating 1400 RPM. For driving the induction motor using the VFD has to receive the speed command input signal from the PLC analog output. So to run the motor at variable speed, we have to provide speed input value to the PLC using SCADA interface, or we can provide this speed input value directly to the PLC program. Depending on this speed input value to the PLC program, the PLC processor generates an integer value in between the range from 0 to 27648. The DA converter of analog output module then converts this integer value to analog output signal in between the range from 0 to 20 milliamps, which is sent to VFD analog input as a reference speed command signal. Depending on the value of analog signal from the PLC, the VFD will adjust the frequency of motor AC power in the range from 0 to 50 Hz. Finally, the AC motor will run at adjusted speed in the range from 0 to 1400 RPM. Thus, on the particular speed input value, the PLC analog output proportionally creates current signal for providing it to the VFD input, and finally, the VFD will adjust the motor speed at that value that is equal to the speed input value to the PLC.
So for speed input value at 0 RPM, the PLC processor generates integer value 0, so the AC motor will run at 0 RPM. Similarly, for speed input 1400 RPM, the PLC processor generates the integer value 27,648. So the PLC analog output creates maximum value of analog signal 20 milliamps. The VFD provides motor power at 50 Hz, and the motor will run at maximum speed 1400 RPM. Thus, on the particular speed input value, the PLC analog output proportionally creates current signal for providing it to the VFD input, and finally, the VFD will adjust the motor speed at that value that is equal to the speed input value to the PLC.
Now proceed to PLC program for motor speed control and analog output configuration of hardware for signal board using the TIA portal software. First, open the TIA portal software and create a new project for Siemens S7-1200 CPU 1214 AC-DC relay. The project has been created for S7-1200 PLC, and we are now on the PLC device configuration window. The PLC selected for this project has no in-built analog output channel. To get analog output, a signal board of one analog output channel has been plugged directly into the front of PLC mainboard. So we need to make software configuration for this signal board in this TIA portal software.
From the tree of hardware catalog, locate the specific signal board for analog output and drag it into the slot on the front of PLC mainboard. Now proceed to configure the analog output channel of this signal board. This configuration will properly interface VFD with the PLC analog output. Select the signal board and navigate to Properties tab. Go to the tab for Analog Output and select channel number 0. On the right side, you will get the option for selecting the type of analog output signal. From the drop-down menu, select Current as analog output type. Note that the current range for this channel has been shown as 0 to 20 milliamps. Now click on the menu for Input-Output Address. On the right side, navigate to Option for setting address for this analog output channel. Change the default address as 100. So in the PLC program, we will use memory address for analog output as QW100. We have come to finish configuration for analog output of PLC hardware. In the next step, we can proceed to PLC programming for motor speed control. Close the Properties window for signal board and move to Programming for motor speed control.
From the project tree, go for Main Organization block and double-click on it to open the window for ladder programming. For programming, we will use norm-x instruction to normalize physical speed input value into a 0.0 to 1.0 decimal range. Then use a scale-x instruction to convert that 0.0 to 1.0 value into raw integer format value within the range from 0 to 27,648 and pass that integer value to peripheral output address QW100. Now proceed to create ladder program using these two instructions. We have come to finish the ladder program for PLC analog output. Here, the norm-x instruction normalizes motor speed input value range from 0 to 1400 RPM into decimal value range 0.0 to 1.0. So we have to provide the speed input value in RPM to the memory address MD20 that will be converted to normalized decimal value in between the range from 0.0 to 1.0. Then scale-x instruction converts the norm-x output into integer format value within the range from 0 to 27,648 and pass that integer value to peripheral output address QW100. Depending on the value written to analog output address, the analog output module generates current signal in between the range from 0 to 20 milliamps, which will be delivered to the VFD analog input. Now compile and download this ladder program to the PLC.
Program has been downloaded to the PLC, and the PLC is ready to provide analog output in the form of current signal.
Now let us check the current signal of analog output using an ampere meter, whether the current signal of analog output matches with the speed input value provided to the input of norm X instruction block. Turn on the monitoring option and proceed to provide the speed input value and check the current signal using the ammeter. Now we will perform a real-time motor speed control operation using the PLC analog output. Depending on the motor speed value to the PLC program, the PLC will provide current signal to the VFD input, and finally the VFD will adjust the motor speed according to speed input value. So let's go to observe how we can adjust the induction motor speed with referring speed input value to the PLC program. We have come to the end of this video. In this video, this has been shown how you can use Siemens S7-1200 Analog Output to operate control devices in a real process application. Through this video, you have come to know about the hardware for PLC analog output, its wiring procedure, hardware configuration, and analog output programming in Tire Portal software. Finally, a test operation of motor speed control using S7-1200 PLC analog output has been performed to get a clear idea about the PLC analog output. If you find this video informative and helpful for you, please like, share and make comments on this video, and don't forget to subscribe this channel.